there. We'll begin to illustrate in this video already using this non-deterministic finite automata. We'll begin to transform this or convert this into their DFA or deterministic finite automata. So this is still, we're still using the string of 1 and 0, where containing 1 and 0 and end with 0, 0, 1, excuse me. So for this one right now, we will begin to check the, okay, let me just give a space for this one here. So Q0 is our start state for DFA, and we'll calculate in the lower part. Now let's try to check. For the Q0, where we'll begin to process first 0, okay? Because we do have 0 and 1. Now from Q0, input 0, where does the transition go? That is staying into the Q0. So therefore, it will loop into that Q0 state for the input 0. Let's try to also define from Q0 where we will begin to also have input 1. Let's try to see it. That is for input 1, that is Q0 and Q1. So Q0 and Q1. So therefore, what you will begin to do, since this state is not available yet, so we can just draw right now Q0 and Q1 and do it here. Then connect that. So this is 0 earlier, and this is for 1. Okay? That is for 1, and this is for 0. Find that. So we're able to illustrate already, and we will be going to go ahead and find each of this one by one. Now we're done with the Q0. Let's try to check the Q0, Q1. Okay, Q0, Q1, where we will begin to find input 0 first. So from Q0, where input 0, that is going to Q0 only. So it will be a union for Q1 and 0. So for Q1, from Q1, input 0, it will go to Q2. Therefore, since that is a union, it will become Q0 and Q2. Does this state is already available? So since that's not, so we can create another node here, state here, which is Q0 and Q2, and that it will become your another state wherein from Q0, Q1 will point to Q0, Q2, and that is input 0. What about for if this one, Q0, Q1, where our focus will be input 1. Now, from Q0, input 1, Q0 input 1, that will go to Q0 and Q1. Q0 and Q1, where you have a union of Q1 and 1. So what is the value of from Q1, which is 1? That is null. Okay? So therefore, because that is null, it will still be in the Q0, Q1. That means to say, since this element, this state is already available, all we just have to do, we just draw the specific, we'll just draw the specific transition from Q0, to Q0, Q1 to itself. So we'll just loop the 1 in this here. So that is 1. Okay. Now, what about the next will be, we're done with the Q0, Q1. Let's try to check the Q0 to Q2. Okay. Q0, Q2, where we'll begin to focus for the 0 input. Now, for Q0, input 0, if mag-input ka 0, it will go back to Q0 only. And it will be a union for Q2 and input 0. From Q2, input 0, that is Q2 and Q3. So it will be Q2 and Q3. So since that is a union, it will become Q0, Q2, and Q3. So since this state is not available yet, so we can create another set of state here, which is Q0, sorry, Q2, and Q3. And from Q0, Q2, that is input 0. Okay. Now remember that our end state or final state is Q4. That is our accepting state for this. Now we're done with the Q0, Q2, 0. Let's try to find the Q0, Q2, input 1. Okay. Now for Q0, input 1, where the transition goes then? It will go to Q0, it will go to Q1, Q0 and Q1. So Q0 and Q1. And then union of Q2 input 1. So Q2 input 1, it will stay in Q2. Q2. Sorry. So that is a union of Q2. So therefore, what will gonna happen, since that is a Q2, it is equals to Q0, Q1, and Q2. So therefore here then, your Q0, Q2, Q0, Q2, input 1 will go to the Q0, Q1, Q2. So that's not here then. So let's try to draw here Q0, sorry, Q0, then Q1. What happened to my kalubat po na ni? So Q0, Q1, and Q2. This is a new state. So from Q0, Q2, where input 1 will be connected here. So that's how you will do. So let's try to find first the Q0, Q2, Q3. Q0, Q2, Q3. Q0, Q2, Q3, input 0. Okay. Now, let's try to evaluate that. Okay. Q0, input 0. From Q0, input 0, that will stay in Q0 itself only. And union of Q2 and 0. From Q2, input 0, it will go to Q2 and Q3. Q2, sorry, Q2 and Q3. And then, what happened to this pen? It's really bad. Q2, Q3. Ano? Q2, Q3 to no? Yeah, Q2, Q3 only. And union again. For the union, Q3 0. From Q3 0, there's no, that is null, null. So therefore the result will be Q0, then Q2, and Q3. So is this available? So Q2, Q0, Q2, Q3 is actually here. So therefore from Q0, Q2, and Q3 will loop to itself for the input 0. Now, let's try to find the input 1 for this. Input 1 for Q0, Q2, Q3, and input 1. So, for Q0 input 1, that is going to Q0 and Q1. And union of Q2 and Q2 and 1, that is staying in Q2. And union of Q3 and 1, Q3, 1. So we'll go to Q4. Okay. So therefore, what will gonna happen here then will become Q0, Q1, Q2, and Q4. Is this existing? Not yet. So we can create another Q0, Q1, Q2, Q4. So Q0, Q1, Q2, and Q4. So since this is Q4 is the final state, so we can consider it this is also a final state. So that is from Q0, Q2, Q3 points to this for input 1. Okay, that is input 1. Now, next, for this one right now, we're done with Q0, Q2, Q3. Well, let's find Q0, Q1, Q2. Q0, okay, let's try to find Q. Okay. Q0, Q1, and Q2, where input 0 first. Just follow lang kay akong ballpen ga bisyo. So Q0, input 0, will go to Q0 only. And then union of Q1 and input 0. From Q1, input 0 will go to Q2. And Q2 input 0. Q2 input 0 will be Q2 and Q3. Q2, Q2, and Q3. So therefore, by their union, become Q0, Q2, and Q3. So is this existing? So Q0, Q2, Q3 is existing. That is for input 0 then. So input 0, 0. And what about for 1? So Q0, Q1, and Q2 for input 1. Okay, let's try to find Q0 input 1. Q0 input 1 will go to Q0 and Q1. Q0 and Q1. Union of Q1 and 1. Q1, 1, that is null. So, union again for the Q2. Where is 1? From Q2, 1 is Q2 only. Stay with Q2. So therefore, the result will become Q0, Q1, and Q2. So is this existing? Q0, Q1, Q2 is existing. So that is pointing to itself. So that is for input 1. And after that, we'll find the transition of the last one. My pen is really not giving now. So just give me a second. Let me just, here's the scissor. Maybe. Okay. Now let's go ahead, and the last will be Q0, Q1, Q2, and Q4, where input is 0 first. So let's try to check from Q0, where input 0, Q0, input 0 is staying into Q0. Union of Q1 and 0. From Q1 to 0 is going to Q2. Q2. And then for union of Q2 and 0. Q2, that is Q2 and Q3. Q2 and Q2 and Q3. And union again. Union of union of Q4 is 0. So Q4 is 0. There is no, that is null. So it will become null. So therefore it will become Q0, Q2, and Q3. So you will point to Q0, Q2, Q3 for 0. Q0, Q2, Q3. Q0, that is Q0, Q2, Q3, 0, input 0. Okay, this is the transition. Lastly, Q0, Q1, then Q2, and Q4 for input 1. Okay, Q0 for input 1, that is going to Q0 and Q1. Q0 and Q1. So union of Q1 and 1. Q1 and 1. So null. So there's no need to indicate here because that is null. So union of Q21 for Q21 is staying for in the Q2. No. Okay, Q2. And then union for Q4 1. For Q4 1, there, that is null. So therefore, the union will become Q0, Q1, and Q2. So from Q0, Q1, Q2, Q4, it will point to Q0, Q1, Q2. Is that existing? So yes, correct. So therefore, that is 1 here. So let's try to validate if it is accepting earlier. Ano to gani? 1, 1, 0, tapos 1, then 0, 1. Let's try to see if this is existing. 1, okay, we'll go to Q0, Q1. Another one will stay here. Then another 0 will go to Q0, Q2. Another one will go to Q0, Q1, Q2. And 0 will go to Q0, Q2, Q3. And 1 will go to Q0, Q1, Q2, Q4, and that is accepted. So this is good. So let's try to see if this is a deterministic. So this one here, Q0, the Q0 is here and 1 is there. For Q0, Q1, 0 and 1 was here, and yeah, that is actually established. For Q0 and Q2, 0 and 1, good. And for Q0, Q1, Q2, 0 is there and 1 is here. And Q0, Q2, Q3, 0 and 1, good. And the last state, final state is 0 and 1, correct. So that is the deterministic finite automata for that particular language. And I do hope that you were able to understand how can we do that particular process for NFA to DFA. So thank you so much and have a great day then, and goodbye.